Today we're going to be doing 9.6. If you will please get out your workbook, page 565, to do this with me. Today and tomorrow we are going to be doing 9.6, and I'm going to be doing it 100% with you. So I need your attention and I need you following along so that you can understand this and don't just copy the things down that I copy, because that won't help you. But I want to do this one with you because they are all word problems, and sometimes word problems get a little confusing, and these ones have multiple steps in them. So stay with me and we will get through this together, and I know you will do awesome. Our first problem. On an archaeological dig, Gabriel separates his dig site into sections with areas of 15 square feet each. So here's a picture to kind of help us. Here's his dig site. He separates them into sections. It looks like in this picture there's at least 4 sections. Each one has an area of 15 square feet. There are 3 archaeological members digging in every section. So 3 people can fit in this section. 3 people can fit here, 3 and 3, no more than 3. And there will be 3 in every site. What is the area of the dig site if 21 members are digging at one time? Let's underline that question so we know what we're trying to figure out. What is the area of the dig site? How big is this dig site going to be if we have 21 people? If we had 3 people, we know that 3 can fit into one section, and that's 15 square feet. But we have a lot more than 3 people. We have 21 people. So, what do I need to find? I need to find the area of the dig site. Pause this video at any time to catch up on writing something or to rewind and listen to it again. What information do I need to use? I can use the area of each section, which is blank. What is the area of each section? Let's see, it said that he separates his dig site into sections with areas of 15 square feet each. Okay, so they're 15 square feet. I'm abbreviating square with SQ. I can use the area of each section, which is 15 square feet, and that there are blank members in each section. How many members are in each section? 3. And don't worry about that one. And that there are 21 members digging. So we have 3 numbers here, 15, 3, and 21, that are going to be important to solving our problem. They were nice enough and gave us a table with everything laid out for us. We have our sections, these are our sections, that's what they look like. The number of members or the number of people, and the area that it will be. So if we just had one section, one of these little sections right here, there would be 3 people, and this area would be 15 square feet. If we had 2 of these areas, of these sections, we would now have 6 people, and the square feet would be 30. We're adding 3 people. This is important. Add 3. We are adding 3 people with each new section. Each section will have 3 more people. We are adding 15 square feet with each new section. 15 plus 15 is 30. 30 plus 15 is 45, and so on and so forth. So, we're looking for some patterns and some rules among this table and these numbers. Possible rules over here. We could multiply the number of sections. Okay, here's my sections. Top row. Multiply my number of sections by something to find out how many members. Let's see what we're multiplying by. 1 times what equals 3? 3. Okay, 1 times 3 equals 3. What is 2 times 3? 6. 3 times 3? 9. 4 times 3? 12. So it looks like we can multiply the sections by 3 to figure out how many members there are. We are multiplying by 3. That's just between sections and the number of people. We haven't even touched the area yet. That's just between those two. Now, we could multiply the number of members by something to figure out the area. So let's see, 3 times something is 15. Look at a multiplication chart if you have one in front of you. Count by your 3s. 3, 6, 9, 12, 15. If I multiply by 5, 3 times 5 is 15. Let's see if that rule of multiplying by 5 works for everything else. 6 times 5 is 30. 9 times 5 is 45. 12 times 5 is 60, and it keeps working. We can multiply by 5. Multiply the number of members by 5 to find the area. So we have a missing number here. This missing number is going to answer our question. Again, our question was, what is the area of the dig site if 21 members are digging at one time? So we have 21 members. We know that information. The problem gave that to us. But the problem did not tell us how big in area the dig site would be. That's what we're figuring out. But we know if we take this number, the number of members, and multiply by 5, we can get the area. So we need to do 21 times 5. Write that down. 5 times 1 is 5. And 5 times 2 is 5, 10. 10. So the area of the dig site, if 21 members are digging, is 105 square feet. Good job. Now the next problem isn't going to have this nice table drawn out for us. But that doesn't mean that we can't use a table to help us solve this. So let's turn the page. Not that one. Your page should look like this. Casey is making a design with triangles and beads for a costume. This is what his design looks like. In his design, each pattern unit adds 3 triangles and 18 beads. Casey uses 72 triangles in his design. How many beads does Casey use? Use the graphic organizer below to solve our problem. Let's underline our question. How many beads does Casey use? What are we trying to figure out? The number of beads, sorry, that sign means number, Casey uses. Again, pause the video to catch up and write that down. What information do I need to use? I can use the number of beads and triangles Casey uses in 1 unit and that he has 72 of these triangles. What information am I using? I'm using the number of beads and triangles, so 3 triangles, 18 beads. This is 1 unit. And the fact that his costume will have 72 triangles in it. All right, let's talk about how we are going to solve this problem. We can solve it by organizing what we know into a table. So let's draw a table. Hopefully I don't mess this up. We're going to have the number of pattern units the number of triangles and the number of beads. Those are the 3 things we're looking for here on our table. All right, I'm not going to draw the other end of my table until I'm done here, because I don't know how long we're going to need it. Okay, remember, this is 1 pattern unit. So let's just start with 1 pattern unit. How many triangles are there? Count with me. 1, 2, 3. And how many beads are there? The problem told us, and we could count them. There are 18 beads. Let's figure out if we had 2 pattern units, how many triangles and beads we would have. Well, we're going to have 3 more triangles. So what is 3 plus 3? 6. And we're going to have 18 more beads. So off to the side here, I'm just going to do 18 plus 18. 8 plus 8 is 16. 1 plus 1 is 2, plus 1 is 3. 36. So we already have a pattern forming. Our number of triangles, we're adding 3 each time. Will you please write add 3 over here? And with our number of beads, we are adding 18 every time. So we have a pattern with our triangles and with our beads. If we have 3 units, 3 of these units, remember that is all 1 unit. 6 plus 3 is 9. And I'll just tell you 36 plus 18 is 54. Okay. Let's just do one more. 4. We will have 12, and we will have 72. So that's where we're at right now. Now the other number it gave us was that Casey uses 72 triangles in his design. So we could go on and on and on with a bunch of numbers here forever until we reached 72 triangles. But because we know that we can find a pattern and rules to help us, we're just going to jump ahead here to 72 triangles. Sorry, Mrs. Butler's just thinking, so hang on just a second. Let's find a pattern between triangles and beads? Actually, back up. Let's find a pattern between the units and the triangles right here. So 1 to 3. How can we get from 1 to 3? We could add 2. Let's see if our rule is adding 2. 2 plus 2 is 4. Nah, that didn't work. 3 plus 2 is 5. No. So adding 2 isn't going to help us. What if we multiplied by 3? 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. So from here to here, we are multiplying by 3. So what times 3 is 72? We're trying to figure out this number up here. What times 3 is 72? We can work backwards, and rather than multiplying, we can divide. So let's do 72 divided by 3 here. 3 can go into 7 2 times. Subtract. Bring down your 2. How many times can 3 go into 12? 4 times. All right, so right here, 24. 24 times 3 equals 72. That's how we figure out that box. Now let's try to figure out a pattern between triangles and beads. So to get from here to here, because if you remember, our question said, how many beads does Casey use when he has 72 triangles? So this is what we're really searching for right here, is the number of beads. 3 times what is 18? Look at a multiplication chart, count by your 3's. 3, 6, 9, 12, 15, 18. Multiply by 6. 3 times 6 is 18. What is 6 times 6? 6, 12, 18, 24, 30, 36. Oh look, 36. It looks like we are multiplying by 6. 9 times 6, you can do your finger trick here. 9 times 6 is 54. So we are multiplying by 6. We can now figure out what this box is. 72 times 6. What is 6 times 2? 12. 6 times 7 is 42, plus 1 is 43. So we have 432. Casey uses 432 beads when he has 72 triangles. All right. We're moving on to the share and show and the on your own section. Again, we are doing these together. I might ask you to stop and solve part of it and then hit play to see if you were right. But this is your assignment that I want you to take pictures of and send to me. Max builds rail fences. For one style of fence, each section uses 3 vertical fence posts and 6 horizontal rails. So look over right here. These are the vertical ones. 1, 2, 3. The horizontal ones he uses 6 of. 1, 2, 3, 4, 5, 6. That is for one section. Our question is, how many rails does he need for a fence that has 27 posts? These are the posts, the ones that go up and down. So how many across sections does he need if he has 27 posts going up and down? First, think about what the problem is asking and what you know. As each section of fence is added, how does the number of posts and the number of rails change? So this was one section. Let's look at 2 sections right here. What changed? Well, we have 3 more posts and we have 6 more rails. So we doubled everything, right? And then when we added a third section, there's 3 more posts and 6 more rails. Next, make a table and look for a pattern. Use what you know about 1, 2, and 3 sections. Write a rule for the number of posts and rails needed for 9 sections of fence. So they put it into a table all nice and neat for us. We don't have to draw our own this time. That is nice. Let's look at what it's saying. Number of sections, 1, 2, 3, all the way to 9. Number of posts, 3, 6, 9 to 27. Number of rails, 6, 12, 18. We are going to look for a rule with just the posts. So look at just the posts. How am I getting from my number of sections to posts? Let me put an arrow right here. This is what we're looking for to answer this. How am I getting from here to here, from sections to posts? Will you please pause the video and come up with a rule? Are we adding by something? Are we multiplying by something? How do I get from 1 to 3, 2 to 6, 3 to 9, and eventually from 9 to 27? Pause the video and hit play when you think you have an answer. I hope you paused the video and you came up with an answer. If you notice, we can multiply by 3. We can multiply the number of sections by 3 to get the number of posts. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. And 9 times 3 is 27. So a possible rule we would write, we can't just write multiply by 3. If you wrote that,